Hello, this is Richard Collins, your instructor in ATM 101, Weather and Climate of Alaska here at the University of Alaska Fairbanks. Today I would like to talk about climate and weather at a site for Unit 15. In this investigation, we will review weather data from Kotzebue for 2 weeks in spring 2013. Kotzebue, located at 66 degrees 53 minutes north, 162 degrees 32 minutes west, sits on the eastern edge of Kotzebue Sound, about 20 miles north of the Arctic Circle. The 2 weeks of weather that we will look at begin on January 27th and March 22nd. At noon on January 27th, the sun rises about 5 degrees above the horizon, while at noon on March 22nd, the sun rises to 24 degrees above the horizon. The sunlight on January 27th is therefore 4.7 times less concentrated on the ground and travels a path in the atmosphere 4.7 times longer than on March 22nd. So we expect to see significant seasonal changes in the solar heating at Kotzebue over this 6-week period. The map shows the location of Kotzebue, and the photo is courtesy of Nick Toon at Weather Underground, which shows Kotzebue in summer. The photo is taken from the northeast, looking across the city toward the southwest and Kotzebue Sound. We start with the week of weather from Unit 3, covering Sunday, January 27 through Sunday, February 4th. In this slide, I present the National Weather Service hourly temperatures as a red curve. I present the climate averages as 3 black curves for the minimum, average, and maximum daily temperatures. These curves for the climate data are taken from Weather Underground and represent the average of the weather conditions since 1999. I first noticed that the temperature can be described in 4 distinct periods during this week of weather. In the first period, there are 3 days, Sunday through Tuesday, with little daily variation, where the daily temperatures are close to the climate average. Second, a 2-day period, Wednesday and Thursday, where the daily temperatures are above the climate average. Third, a 1-day period, Friday, where there is a rapid drop in temperature and the daily temperatures are below the climate average. And finally, a 2-day period, Saturday and Sunday, where there is a rapid rise in temperature and the daily temperatures are above the climate average. I will focus on 3 days from these periods. The first day, Monday, January 28th, is in the first period. On Monday, there is a high temperature of 2 degrees Fahrenheit, a low temperature of -6 degrees Fahrenheit, giving an average temperature of -2 degrees Fahrenheit and a range of 8 degrees Fahrenheit. The daily average is 1 degree Fahrenheit higher than the climate average of -3 degrees Fahrenheit. On Monday, we also see evidence of a diurnal cycle where the temperatures are warmest in the late afternoon about 1800 or 6 p.m. Remember, this far west in Alaska, solar noon is at 1400 or 2 p.m. The second day I focus on is Thursday, January 31st, in the second period, where the high temperature was 11 degrees Fahrenheit and the low temperature was 1 degree Fahrenheit. This gives an average daily temperature of 6 degrees Fahrenheit and a temperature range of 10 degrees Fahrenheit for the day. The daily average is 9 degrees Fahrenheit higher than the climate average of -3 degrees Fahrenheit. Finally, the third day is Friday, February 1st, in the third period. On Friday, the high temperature was 1 degree Fahrenheit, the low temperature was -22 degrees Fahrenheit, the average temperature was -11 degrees Fahrenheit, and there was a temperature range of 23 degrees Fahrenheit. The daily average is 8 degrees Fahrenheit lower than the climate average of 3 degrees Fahrenheit. I now present the National Weather Service hourly pressures measured at Kotzebue. The pressure is plotted as a green curve, and we see that there are significant changes through the week. There are maximum pressures on Sunday night, and again there's a second maximum on Friday afternoon. Over the course of the week, the pressure changes by 40 millibars, which is significant. The higher pressure on Monday and Friday corresponds to the colder periods we saw on the previous slide, and the lower pressure on Wednesday and Sunday correspond to the warmer periods that we saw on the previous slide. We now examine the humidity at Kotzebue in Unit 3. In this slide, I present the National Weather Service hourly dew point temperatures and relative humidity over the 8-day period. The dew point is plotted as a blue curve and the relative humidity is plotted as a broken brown curve. We start with the dew point temperature, which is the absolute measure of humidity. The variation in dew point from minus 15 degrees Fahrenheit to plus 15 degrees Fahrenheit is significant, and based on the humidity tables in Chapter 6 of the textbook, corresponds to changes of a factor of about 3 in the amount of water vapor in the air. The periods of lower humidity correspond to the colder periods with higher pressure. This indicates that the changes in temperature, pressure, and humidity are due to passages of different air masses over Kotzebue. Note that the relative humidity offers a different perspective than the dew point temperature. On Friday, February 1st, the relative humidity remains high, near 80%, while the actual humidity, as represented by the dew point temperature, falls. This is because the temperature fell on Friday. At these colder temperatures, the capacity of the air to hold water is lower, and so the ratio of the actual amount of water vapor present to the maximum amount of water vapor that could be present at this temperature increases. Thus, while the humidity changes significantly in the second half of the week, the relative humidity remains relatively constant. On Monday, when the humidity is relatively constant, we see that the relative humidity is highest at 55% at 0300 or 3 a.m. during the coldest part of the day, and lowest at about 45% at 1800 or 6 p.m. in the warmest part of the day. We now look at the first of our weather maps for Monday, January 28th. Kotzebue is indicated by a star on the map. We see on this day that there is strong high pressure influencing Kotzebue. The shading from the infrared satellite image indicates thin clouds overhead. The isobars indicate that the winds are from the southeast blowing toward the northwest across the interior of Alaska to west central Alaska. Thus, the air at Kotzebue is expected to be cold and dry under continental influence. This is consistent with the cold and dry conditions measured by the station at Kotzebue. Our second weather map is for Thursday, January 31st. We see on this day that there is a stationary front with a low influencing Kotzebue. Warmer and moister air appears to have moved north from Bristol Bay to the Seward Peninsula. The shading from the infrared satellite image indicates thicker clouds, and it is snowing in the region. The low with warmer air and thicker clouds is consistent with the station observations of higher temperature, lower pressure, higher humidity, and no clear diurnal cycle in the temperatures. Finally, for Unit 3, we look at the weather map of Thursday, February 1st. We see on this day that strong high pressure has re-established itself with thin cloud over Kotzebue. The isobars indicate airflow from the east to west across north of Alaska. That airflow brings air from cold and dry interior Alaska to Kotzebue. The infrared satellite image is dark with very little evidence of clouds over interior Alaska and with thin gray bands over west central Alaska. This suggests that the cloud cover over Kotzebue is thinner than on Thursday. This weather pattern is consistent with the station observations at Kotzebue on Friday. We now examine the week of weather from Unit 10, covering Friday, March 22nd through Friday, March 30th. We first notice that the temperature can be described in 3 distinct periods. First, a 2-day period, Friday and Saturday, where the daily temperatures are close to the climate average. Second, a 4-day period, Sunday through Wednesday, where the daily temperatures are mainly below the climate minimum temperatures. And finally, a 2-day period, Thursday and Friday, where there is a rapid rise in temperature from below to above the climate average. We also notice that throughout all 3 periods, there are diurnal variations in the temperatures each day. I focus on 3 days from these periods. First, Friday, March 22nd, in the first period, where the high temperature was 1 degree Fahrenheit and the low temperature was minus 18 degrees Fahrenheit. This gives an average of minus 9 degrees Fahrenheit and a daily range of 19 degrees Fahrenheit. The daily average is 11 degrees Fahrenheit lower than the climate average of 2 degrees Fahrenheit. On Friday, we also see evidence of a diurnal cycle where the temperatures are warmest in the late afternoon, about 1800 or 6 p.m. Remember, this far west in Alaska, solar noon is now 1500 or 3 p.m. due to daylight savings time. The second day we focus on is Monday, March 25th, in the second period, where the high temperature was minus 5 degrees Fahrenheit and the low temperature was minus 21 degrees Fahrenheit. This gives an average of minus 13 degrees Fahrenheit and a range of 16 degrees Fahrenheit. The daily average is 15 degrees Fahrenheit lower than the climate average of 3 degrees Fahrenheit. Finally, the third day, Friday, March 29th, is in the third period, where the high temperature was 15 degrees Fahrenheit, the low temperature was 0 degrees Fahrenheit, and the average was 8 degrees Fahrenheit with a daily range of 15 degrees Fahrenheit. The daily average is 5 degrees higher than the climate average of 2 degrees Fahrenheit. The strong diurnal cycle in temperature, with daily temperature ranges of about 15 degrees Fahrenheit, are consistent with the increased longer days and higher solar elevation angles in March at Kotzebue. Over this week of weather in Unit 10, there are relatively small changes in the surface pressure. The pressure varies by about 12 millibars over the whole period. This is not the dramatic change in pressure that was observed during the week of weather in Unit 3. In examining the humidity, we again start with the dew point, which is the absolute measurement of humidity. The dew point varies from daily values of minus 15 degrees Fahrenheit to minus 20 degrees Fahrenheit through the first two periods, and then increases to about 10 degrees Fahrenheit at the end of the week. The increase on Thursday and Friday from minus 20 degrees Fahrenheit to 10 degrees Fahrenheit is significant, and based on the humidity tables in Chapter 6 of the textbook, corresponds to changes of a factor of about 4 in the amount of water vapor in the air. The period of higher humidity corresponds to the warmer period, and this indicates that there was a change in air mass over Kotzebue on Thursday and Friday. Note that the relative humidity offers a different perspective than the dew point temperature. The relative humidity values of about 80% during the middle of the week are similar to those at the end of the week, even though the actual humidity is much lower. This behavior again reflects the colder conditions during the middle of the week and the warmer conditions at the end of the week. On Friday, March 22nd, the relative humidity is highest at night when it is coldest and lowest during the day when it is warmest, about 1800 or 6 p.m. On Monday, March 25th, the relative humidity is again lowest during the warmest part of the day, even with the increase in absolute humidity at that time. We now look at the first of the three weather maps for Unit 10. This is the weather map for Friday, March 22nd. Kotzebue is indicated by the star on the map. We see on this day that Kotzebue is between a strong high to the west and a low to the east. The isobars indicate northerly winds at Kotzebue, and the shading from the infrared satellite image indicates thin clouds overhead. This is consistent with cold and dry conditions, with a large temperature range measured by the station at Kotzebue. The second weather map is for Monday, March 25th. We see on this day that Kotzebue is still under the influence of the high-pressure system to the west, and that the winds continue to be northerly. Cloud cover remains thin, with the satellite image showing a dark grey shading. Finally, in the third weather map for Friday, March 29th, we see that Kotzebue is now under the influence of a low-pressure system to the south. This low is associated with the arrival of warmer and moister air from the south. The counterclockwise rotation around the central low shows a warm front moving north and a cold front moving south. Even with the snow, the cloud cover appears broken enough to allow daytime heating, and so the afternoon temperatures can rise above the climate average high. Summary of Unit 3 weather. The big picture for the first week in Kotzebue is that the week starts with weather that represents the climate average, January 28th, and then gives way to days where the weather alternates warmer and colder than the climate average, though the higher, January 31st, and lower temperatures, February 1st, average out to near climate average. The changes in dew point temperature reflect the passage of different air masses over Kotzebue. The weather of this week highlights one of the key questions about weather and climate. An average temperature can represent very different patterns of weather. The average can reflect unchanging and boring temperatures, or highly variable and exciting high and low temperatures that average out to the same thing. And we see that pattern this week as we go from the beginning of the week of weather to the end of the week of weather. Summary of Unit 10. The big picture for the second week in Kotzebue is that the week starts with weather that is much colder than the climate average, March 22nd and 25th, and then gives way to a day where the weather is warmer than the climate average, March 29th. The changes in dew point temperature again reflect the passage of different air masses over Kotzebue that come from either the Arctic with northerly winds or from the North Pacific with southerly winds. Clearly, these two weather patterns result in very different temperatures at Kotzebue. If we think of climate as the pattern of prevailing weather, then if changes in the circulation will result in a shift from the Arctic-dominated pattern to a Pacific-dominated pattern, Kotzebue would see a radical change in climate.